Hello students, welcome to physics class. Today we starting a new lesson in physics, that is chapter number 9 from NCERT textbook, the force and laws of motion. In the last chapter, that is in motion, we describe the motion by using the term distance, displacement, velocity, speed and acceleration. But now we discuss what is the cause of motion. If there is any cause of motion, what is the nature of that cause? In this chapter, we are going to study what is the cause of motion and what is the nature of that cause. The problem of motion and the cause of motion puzzled the scientists and philosophers for many centuries. We know that once you are hitting a football placed on a ground, it moving for some distance, but it's not moving forever. After sometimes it may comes to stop. These observations suggested that the natural tendency of every body is to be at rest. People believed so. This belief continued until the scientists Galileo Galilei and Isaac Newton proposed a complete different approach to study the motion. In this chapter, we are going to discuss what are the laws proposed by Isaac Newton about motion. You know that from our everyday life, to make a body in motion from rest or to make a body to rest from motion, we have to take some muscular effort. Usually, this muscular effort will be a push or pull. And we call that muscular effort as force. In the last year, we learned that a force is a push or pull which can change the state of rest or uniform motion of a body. To explain what is force, we have to discuss what force can do. You know that when you are applying a force, a body on rest, we can make the body into motion. Or if you are applying a force on a moving body, sometimes it may come to stop or the direction of motion may be changed. When you are applying a force on a body, sometimes we can change the shape and size of the body. So the force is nothing but it may be a push or pull which can change the state of rest or uniform motion of a body. Let us see the definition of force. The force is defined as the force is the cause which changes or tends to change the state of rest or of uniform motion of a body in a straight line. The force is the cause which changes or tends to change the state of rest or of uniform motion of a body in a straight line. Suppose we have a body which is placed on a horizontal surface like this. This body is connected with the two strings X and Y. Here, a body which is placed on a horizontal surface and the body is connected with the two string X and Y. Suppose we applying a small force in the string X towards this direction, and you know that the body will sometimes move in that direction. After that, we are applying the force on the string Y towards left side, and you can note that the body is moving towards left. But if you are applying the force on both string, if the force is applied on both string, if equal forces are acting on the string, the body will continue at rest. The body will not move in any direction, the body will at rest. The reason is that the forces are equal but they are opposite direction. If you are calculating what the total force acting on the body, the total force acting on the body is equal to 0. Now we call it is a balanced force. It's a balanced forces. The balanced forces are if a sum of a number of forces acting on a body is 0, then such forces are said to be balanced force. If the sum of a number of forces acting on a body is 0, then such forces are said to be balanced force. Here the two forces are acting on this body, but the total force or the sum of the force is 0. That's why the body is not moving. Please understand, if the balanced force is acting on a body, if it is at rest, it will continue in rest. If it is in motion, it will be ever in motion. If a balanced force is acting on a body. And now, if a unbalanced force is acting on a body, let us see what is the condition for unbalanced force. For that, here we have a huge block of mass which is placed on a horizontal surface, and suppose if you are pushing this block in this direction, we are applying a very small force only, but the box will not move because it is a very heavy box. What actually happens is that we are applying a very small force only, it is balanced by frictional force. We know that there is an opposing force against our applied force, and we calling as friction, which is opposite direction of the applied force. They balance each other. Now it's a balanced force actually. Suppose we are applying a little more force, we are increasing the force, we are pushing it hardly. Again, you can see that the box is not moving because again the friction is balancing the applied force. But if you still push it hardly, after some times the box may start moving. By the time the frictional force is not balancing the applied force, or otherwise you can say the applied force overcome the friction. Now the total force is not 0. Such time we can call is the unbalanced force. Unbalanced force is acting on the block. If the sum of a number of force acting on a body is non-zero, then such force are said to be unbalanced force. If the sum of a number of force acting on a body is non-zero, then such force are said to be unbalanced force. If an unbalanced force is acting on a body at rest, the body can make into motion. If an unbalanced force is acting on a moving body, it gets accelerated. Now let us discuss the Galileo's experiment to demonstrate the motion. Galileo explained the motion, the concept of motion, by using two inclined planes. Here we have two inclined planes which make the same angle with the horizontal. Once you are releasing a ball from this inclined plane, it rolls down through this inclined plane. When it rolls down, its speed increases. When it reaching the bottom, its speed is maximum. And it rolls up through this inclined plane. And according to Galileo, the ball will rise to the same height. If it is released from a height h, on the other plane, the ball will reach the same height h. But in our real life situation, it's very difficult to achieve the same because due to friction, it cannot reach the same height. But Galileo, according to Galileo, if the friction is very less, the body will reach the same height on the other plane. After that, Galileo decreased the angle of inclination of the second plane. If you are decreasing the angle, once the balls want to reach the same height, it traveling more distance to this other plane. If it travel more linear distance, then only it can reach the same height because its slope is increases. Further, if you are increasing the slope, again it travel more distance to reach the same height. Finally, if you are making the angles to 0, never the ball can reach the same height. So it will travel forever to with the same speed to achieve the height, but never it can achieve. So it will continue its motion forever with the same speed. From all this observation, from all this experiment, Galileo concluded that no force is required to maintain the uniform motion. If there is no external force acting on a body, it will continue its state of rest or uniform motion unless it is acted by some external force. And that termed as Galileo Law of Inertia. That is, according to Galileo Law of Inertia, a body moving with a certain speed along a straight path will continue to move with the same speed along the same straight path in the absence of external force. If no external force acting on a body, it will continue its state of rest or uniform motion. Every body having that tendency to continue its state or rest, the state of rest or uniform motion. And Galileo called that inability of the body to change its state of rest or uniform motion by itself as inertia. Later, Sir Isaac Newton studied about the Galileo's experiment and Galileo law and proposed the three laws of motion. They are known as Newton's laws of motion. We will discuss about the Newton's laws of motion in the coming section. That's all for today. Thank you.